Welcome to Lesson 2, Area of a Trapezoid. Our objectives are to find the area of a trapezoid and then use Pythagorean theorem as well as area to help us solve for missing links. The area of a trapezoid can be derived from different combinations of shapes that you already know. Down here there are 6 ways to calculate the area of a trapezoid. You can split it into 2 parallelograms. You can do a rectangle-triangle combination or a lot of different things. I like to think of it as 2 triangles. So when I explain the area, I'm going to use that idea, 2 triangles. Okay, let's understand the area equation, the area of a trapezoid. First of all, what is a trapezoid? Well, a trapezoid has 2 bases, A and B. It has 2 sides that are not parallel to each other. Therefore, it is not a parallelogram. A trapezoid also then has a height that is perpendicular to the base. And here is an example of a trapezoid. You can have a trapezoid that looks like this. You can have an isosceles trapezoid where the 2 sides are the same measure and they form the same angle down here where D and C would be. But again, these 2 legs here, C and D, are never going to be parallel to one another. So there's many different looking trapezoids, but the key thing to keep in mind is that you have one set of parallel sides, and that is it. Here's the equation for area, and this can be written in different ways. This is probably the easiest way to remember. And with this way, you add your bases together, multiply by height, and divide by 2. Does it sound familiar? This is similar to a triangle. That's why I like to think of it as 2 triangles, because remember that area for a triangle is base times height divided by 2. So look at where this dotted line is. If I separate this into two triangles, then basically if I look at this bottom triangle, I have base A times this height divided by 2 would give me that area. And then for the top triangle, I would have base B times the same height divided by 2. And if I add the 2 areas together, I would have the area of a trapezoid. So really, we have height in common, we have division by 2, and then we just have our 2 bases. So we always think of a trapezoid as adding both bases together, multiplying by height, and then dividing by 2. Let's try some examples. Okay, here we have a trapezoid, and notice again that our height has to form a perpendicular with our base. So in this example, we have a base of 4, another base of 8, and a height of 5. That's exactly the amount of information we need in order to calculate the area. So remember that the area is base 1 plus base 2, order doesn't matter, times our height, which is 5, divided by 2. Just be careful of your order of operations. So I'm going to do that parentheses first and get 12 times 5 divided by 2. Since now all we have is multiplication, order doesn't really matter. I could divide 12 by 2 and then multiply by 5, or I could do 12 times 5 and then divide by 2. I'm going to go ahead and simplify my numerator just to keep it simple, and I'll get 60 divided by 2, which then gives me 30 centimeters squared. And it's that simple. So let's look at this second example. Well, again, I need to find the area using the area formula. So I'm going to have the area of one of my bases, which is 8. And notice I'm using parentheses when I add my bases together. But what is this second base? I know that from here to this dotted line is 4, but what about from this dotted line to the end? Well, notice that it sits parallel to this, 8, and it's the same distance. So this is also 8, which gives me a total of 12. So my other base is 12. My height, do I know my height? Here's my height, right? But there's no measure there. But again, notice that this is a square in here. So every side length is the same. This is going to be 8, and this is 8, and this is 8, and this is 8. And you can tell because this side is 8, this also represents my height. So the height of this trapezoid is going to be 8 divided by 2. Again, following my order of operations, 8 plus 12 is 20. And then I'm going to multiply that by 8 and divide by 2. So I'll get 160 divided by 2, which means the area of this trapezoid is 8 units squared. All right, that's basic area. Let's make it a little more difficult. Here we need to find the area of this trapezoid. Now if you'll notice, we have our heights drawn in. We have a little right angle here, meaning that this is a right angle, which means that these triangles are both right triangles. Okay, what am I missing? I'm missing the base. In order to find the area, I need to have my base. Well, I know that from here to here is 8. But what I don't know is this distance, and I don't know this distance. So we'll just come up with some variables. We'll call this one P, and we'll call this one Q. And I need these two distances in order to find out the length of this bottom base. Well, how can I do that? Well, if you'll notice, like I said, this is a right triangle, and we have 2 out of 3 sides, so we can use Pythagorean theorem to solve for P. And if you'll notice, this trapezoid is a special trapezoid. This is an isosceles trapezoid. The way you know that is because this leg is 8, this leg is 8. Therefore, you know that they are equivalent. So this base here and this base will be the same measure. So in reality, I could erase this Q, and I could call this P as well, because these will be the same measures. Let's go ahead and use Pythagorean theorem to find this portion of my base. Well, my hypotenuse is 8. One of the legs is 6, and one of the legs is P. So if you recall, we have a squared, which we'll call P, plus b squared, which is 6, is going to be equal to c squared, which is our hypotenuse, which is 8. Remember, it's important to make sure that you get the hypotenuse in the correct location. So if we simplify, we have p squared plus 36 is equal to 64. Let's fix that a little. To solve, I would need to subtract 36 from both sides, and I would get p squared is equal to 28. If we find the square root of 28, we get 5.29, and we'll just call that 5.3. So P is now equal to 5.3. And also recall that the reason I took the square root is I need to still solve for P. And right now we have P squared. To undo the square, we take the square root. So we know that this distance, P, is equal to 5.3, which means that this distance is also equal to 5.3. Now I can find the total of my base by taking 5.3 plus 5.3 plus 8. So let's do that. 5.3 times 2 plus 8 gives me a base of 18.6. I'm now ready to find the area of my trapezoid. I've plugged everything into my equation. I have one base plus my second base times my height divided by 2. Following my order of operations, I would go ahead and add this together first. So I would get 18.6 plus 8 is 26.6 times 6 divided by 2. Now this time I'm going to change how I do this. I could multiply these two and divide by 2 on my calculator, but if I don't want to use my calculator, I can take 2 into 6 and get 3, and then I can just multiply 26.6 by 3 and get 79.8 centimeters squared. All right, let's try another example. In this example, we need to find the missing measure. Now notice in this example I'm not given a diagram, but you should still draw a diagram to help you solve these problems. So here we have a trapezoid. So I'm going to draw a trapezoid and label it. The area is 56 centimeters squared. The bases measure 6 and 10, And what I need to find in this trapezoid is my height. So this distance here. That is the unknown. Let's go ahead and set up our equation. So we know that our area is going to be one of the bases plus the other base times height, all divided by 2. Let's fill in what we know. We know then that our area is 56. We know what our bases are. They're 6 plus 10. We don't know the height, but we do know that we need to divide by 2. Let's go ahead and simplify what we have. So now we have 16h divided by 2. 16 divided by 2 is 8. So now I can write this as 8h. And then how do I solve for h? All I have to do is divide by 8. And I get a height of 7. 56 divided by 8 is 7. And we are using centimeters. So now I've found the height. Let's try one more example. Here we have another trapezoid. So let's go ahead and draw our trapezoid. And in this trapezoid, we are given the area of 27. We know that one base measures 5, and the height, this distance, measures 9. We need to find the measure of the other base. We'll call this B2. All right, so again, I'm going to write out my formula so I have it close. Base 1 plus base 2 multiplied by height divided by 2. And then, very simply, we just need to fill in what we have. Well, we have the area again. We have one of the bases, but we don't have the other base. We know the height this time, and we would divide by 2. Now, in a situation like this, because we have an unknown variable here in our numerator, we would want to remove the 2 from the denominator. We don't want that there because this is going to be difficult to deal with. So to get rid of the 2, we would just multiply by 2. So we're going to do the opposite. We're dividing by 2. In order to get rid of it, we multiply by 2. 2 divided by 2 is 1, and now there's no more division on this side. 2 times 27 over here is 54. So now we have 54 equals 5 plus b, keep these in parentheses, times 9. Well, I can't do anything with the parentheses because I don't know b. I could distribute the 9 into the parentheses, and that's certainly one way to do this. But I find it easier just to get rid of everything around the parentheses. So now I'm going to get rid of the 9 by dividing both sides by 9. 54 divided by 9 is just 6. And then on this side, 9 divided by 9 again goes away. That turns into 1. So now I'm just left with 5 plus b. I no longer need parentheses. I can subtract 5 from both sides, and I will get an answer of 1. So this other base is equal to 1 centimeter. And that concludes our lesson on finding the area of a trapezoid. So hopefully, after today's lesson, you're able to find the area of a trapezoid given all the appropriate information. But then you can also use what you've learned before, including Pythagorean theorem, and how to solve for a variable in an equation in order to find missing links in your trapezoids.